Welcome back to Chemistry with Mrs. Mays. Today we're going to talk about significant figures, or as we like to call them, sig figs. Remember we talked about uncertainty in every measurement. The uncertainty in measurements, spelling mistake, in measurements are based upon the type of instrument that you use, because it's going to limit exactly how accurate your measurement can be. It's always going to be made up of a certain number of digits that we know. We call these our certain digits because there's markings on the instrument for these. And then after the markings, I need you to estimate one more digit so that you have in every measurement certain digits, and then the very last digit will always be an estimation to the best of your ability. Let's look at what that means. Okay, so for example, we're going to use a ruler to measure the length of a metal rod. This ruler has markings in inches. Oh, what a horror. That should be in centimeters, right? But this one's using inches, and we have markings for every tenth of an inch. So we can measure past the one. We have 1, 2, 3, 4 marks past there, but it's not quite to the 5th mark. So we can't say that it is 1.5 inches. It's not quite there. We're going to have to estimate how close is it between the 4th mark and the 5th mark. And I think it's a lot closer to the 5th mark, so we called it 1.48 inches. So the 1 and the 4 are certain numbers because I have a mark for that. But the 8 in the hundredth place is the uncertainty digit based upon the ruler that we're using. That was my estimate. You might have guessed it at 1.47 or 1.49 or something similar, but not exactly the same, because it just depends on your interpretation of that measurement. So significant figures are the numbers of digits that we know for sure, plus that one extra estimate. Exact numbers in a measurement are going to be counted, but we don't consider them to have significant figures. Like if you have 11 soccer players, that's an exact number, a counting number, and you're not going to have 11.5 soccer players. That doesn't make any sense. That's not a real thing. Well, it would be creepy, right? Just use for counting numbers, unlimited sig figs. All other numbers, except for 0, are going to be considered significant, and some zeros are significant and some zeros are not. This can be a little bit complicated, but I'm going to show you an easy way to break it down. So check it out. When do the zeros count? We use a technique called Pacific and Atlantic. So on the map of the United States, the Atlantic Ocean is on the east side, Atlantic, and the Pacific Ocean is on the west side, Pacific. And I don't really need a geography lesson, but I want you to remember the A stands for when your decimal is absent. And the P stands for the times when a decimal is present in the number. So look at the first example, 3,200. There's decimal is absent from this measurement, so I'm going to fly in with my arrow from the Atlantic side, from the east, and fly in until we crash into a non-zero digit. Then we start counting. And there's a 3 and a 2, so this number has only 2 digits that are truly significant. So we call that 2 sig figs. But in the next example, we have a decimal. Since the decimal is present, this time we have to fly in from the Pacific side until we hit a non-zero digit, which happens right away. I cannot cross anything out. So I count all of these digits as significant. That measurement has 4 sig figs. So the way you write your measurement, with decimals or without, is going to be very important. Here's another one, same number, and now I've got a decimal in the middle, so we fly in from the Pacific side, and look, we crashed into a number right away, so I have 4 sig figs. So the last measurement, though, is accurate to the tenth of the decimal place. The other ones were only to the ones place, and this one to the hundreds place, right? Hundreds? Thousands? No, hundreds place. Wow. Why do I have to question myself? Let's do another couple examples to make sure you get it. So here we have the decimal present, fly in from the Pacific side. That guy's got 4 sig figs. And this example, we also have a decimal, so I fly in from the Pacific side and keep going until we hit a non-zero number. So in example B, I have only 1 sig fig. Example C has decimal absent, right? No decimal in this one, so we fly in from the Atlantic side until we crash into a non-zero digit. That one's got 2 sig figs. D has a decimal, so come in from the Pacific side because the decimal is present, and we don't get to cross anything out there. Same for E, we're not crossing out anything, 3 sig figs. Now F has a bunch of zeros in it. Well, the letter F doesn't, the number does though. So we fly in from the Pacific side though because there's a decimal there. And since the decimal is present, we fly in from the Pacific, and I don't get to cross out anything because I crash into a non-zero number right away. The same is true for G. I have a decimal present, so let's fly in from the Pacific side, and I don't get to cross out any of those zeros. I keep them all as meaningful digits in my measurement. That's what sig figs are, the meaningful digits in your measurement. All right, we will practice this together in class. Every time you write down a measured value, we're going to talk about its sig figs.